I've seen a lot of people rush to grab the cheapest resistance meter they can find, only to end up wrestling with unstable readings or a display that fades after a few weeks. The regret that follows is real. You've spent time, money, and a bit of pride on a tool that never quite lives up to the job. That's why I wanted to take a step back and see if the Hioki RM354401 actually feels like a smarter buy, instead of just another budget disappointment. Link is in the description if you want to check the product details on Amazon. When you're setting up a lab, a repair bench, or even a hobbyist work area, the first question is always the same. Will this meter give me the confidence to trust the numbers I'm reading? The RM354401 positions itself as a precision resistance meter with an external I/O interface, promising basic accuracy across a range from virtually 0 up to 3.5 M. That's a pretty wide span, and it means you could be measuring the tiny coil resistance in a vintage audio transformer one moment and the bulk resistance of a power cable the next. The key is how that translates into everyday use, and whether the trade-offs built into the design make sense for the kind of work you do. First, let's talk about the measurement approach. The meter supplies a test current up to 300 milliamperes, which is generous for a handheld instrument. In practice, that means you can force a decent current through higher resistance components without having to wait for the meter to settle. I tried it on a set of 1K precision resistors that I use for calibrating my own equipment. The readings snapped to within a few parts per thousand, which is about as tight as I'd expect from a tool in this price tier. For most electronics technicians, that level of accuracy is more than sufficient for troubleshooting and routine verification. One of the hidden strengths of the RM354401 is its external I/O capability. The instrument includes a connector that lets you hook up an optional LED comparator attachment. In a noisy workshop, you can set up the comparator to give you a clear visual cue. An LED will flash whenever the resistance crosses a threshold you define. I set mine to light up if a connector's resistance climbed above 5, which is handy when I'm doing quick continuity checks on wiring harnesses. The high-volume judgment tones that come with the comparator also make it possible to work with one hand while listening for the tone, a small but surprisingly useful feature when you're juggling tools. Now, no instrument is without its quirks. The basic accuracy claim is a double-edged sword. Hioki doesn't list a tighter tolerance than 0.5% of reading, and there's no mention of temperature compensation. In a climate-controlled lab, that's fine. But if you're moving the meter between a garage in July and a basement in January, you might notice a drift of a few ohms on the lower end. The display is also modestly sized. It fits comfortably in one hand, but reading 4-digit numbers at the far edge can strain the eyes after a while. If you spend most of your day staring at tiny decimals, you'll probably appreciate a larger screen, but for spot checks the size is acceptable. Who should consider this meter? If you're an electronics hobbyist, a field service technician, or a small shop repair professional who needs to verify resistances across a broad range without breaking the bank, the RM354401 hits the sweet spot. Its ability to push a relatively high test current means you won't be stuck waiting for low current measurements to settle, and the external I/O gives you flexibility that many entry-level meters lack. The optional LED comparator makes it practical for on-the-fly checks, which is a nice touch for anyone who likes to keep both hands free. Who might want to skip it? If you work in a high-precision calibration lab where you need sub-0.1% accuracy and built-in temperature compensation, you'll probably outgrow the RM354401 quickly. Likewise, if you rely heavily on data logging or need integrated USB connectivity for automated test rigs, you'll need a more advanced instrument. The lack of a built-in data export function means you'll have to manually record readings, which can be tedious if you're logging dozens of points per session. A practical scenario I ran through involved checking the resistance of a heating element in a coffee machine. The element's resistance sits around 2, and a faulty connection can add a fraction of an ohm that throws the whole system off. Using the meter's 300 milliamperes test current, I could quickly determine the element's resistance and spot an intermittent fault that a lower current meter missed. The LED comparator, set to trigger at 2.2, blinked every time the contact was loose, giving me an audible and visual cue that saved me a few minutes of hunting. Another real-world use case is troubleshooting a high-end audio amplifier's output stage. The output transistors have small, milliohm scale resistances that affect biasing. While the RM354401 isn't a micrometer, the guard jack probe accessory lets you increase measurement current and